Hello everyone! In today's episode, we will step away from selecting the data from the already existing tables and we'll dive into the world of the so-called data definition language. So basically a group of SQL statements that allow us to create, and in this episode we'll take a look at creating tables. So creating a simple table is really straightforward. So let's take a look what would make sense. We have the countries and we have people, right? And I would currently suggest that, for example, we create a table which will store information about jobs, right? So different people can have different jobs. Therefore, what we can do is we can just say create table and then the name of the table. Let's say jobs. And then you open and you close the parentheses, you put a semicolon at the end. Now, in between these parentheses, what we'll be doing is we'll be creating columns, right? So every table needs to have at least one column. It's common to include a column named ID in a table. And a column named ID usually would be something called a primary key. But before we get to what primary key is, every column in a table needs to have a data type. Now, there are different data types in SQL. I will not go over all of them, but the basic ones that you need to know are character columns, and then there are so-called chars, which are fixed length characters, which means that if you create such a column, if you say create it as length 10 and you put a string which has only 5 letters in there, the rest 5 would be just white spaces. And then you have varchars, so these are variable length. Basically, there are the length that the content, and they usually have the maximum defined. What you then have is, of course, the numeric data types. So basically the most simple would be an integer. So these hold up only a certain range of numbers. There are usually big integers, and then there are the decimal data type. So basically there is the decimal data type, right? Which allows you to store the decimals with a comma in between. Now there are also dates and date times. So basically you can store dates and you can store timestamps in a datetime or a timestamp type column. These are a little bit more complex. And now the basic data types would always be very similar in how they behave and how they are called in every database. However, when we come to the more advanced data types and their behaviors, right? So basically timestamps are often different, how decimals behave is slightly different. You have to always sort of understand what you are doing. This is why it's not the simplest of a topic to generalize and to talk about it once for all the DBMSs out there. But let's get back to the basics, right? To our varchars, to our integers, because this is like the 90% of what you will be using. So an ID column very often is an integer, and I'll create this as an integer. And this is sufficient, right? So this syntax means that we create a column which is called ID with a data type of an integer, and a column must always have a data type. Then let's say we also want to create a column named job title. And the job title, let's say, is a varchar. In Oracle, we often say varchar 2. And for the current level of knowledge, it's irrelevant what's the difference between varchar 2 and varchar. These, in the current releases of Oracle that we are on, behave exactly the same, but you should always use varchar 2 for now. Varchar without a 2 is a legacy data type, and you shouldn't use it. It may be used for something else in the future, but just stick to varchar 2 for now. And now we need to define a maximum length, and I just say 255. And so basically you cannot insert a content that is longer than 255 characters here. Then let's also say a salary, right? And a salary for a given position, let's say that's also an integer. Now, so now what we have is we have a table called jobs with 3 columns. So we have an integer ID column, a job title, which is a varchar, and then we have a salary, which is also an integer. And if I press run statement, we will see that the table jobs was created. Okay, let's try to verify that. Let's try to select something from this table. So let's go ahead right here. Let's execute this part. And we can see that indeed here we have some columns. They are empty because we have not added any data so far. Now we have already learned how to create a table, but let's now take a look at how we can drop a table. So it's very simple. You just say drop table and then the table name. And now if I execute this, we get a notification that the table has been dropped. Once again, we can create this and we can drop it once again. So what else can we do? Well, we can enforce a column to be the so-called not null, and a not null column cannot contain a null value. So I will just create this ID right now as not null. First I need to drop it, and then I can create it. So basically now, if you refresh it on the left-hand side here, you will see the new table here, which is called jobs. And then if you go into the columns tab here, you'll see that an ID is nullable no. This basically is Oracle saying to you that this column cannot have a null value in it. So how do we verify that? We need to learn something additional. We need to learn one of the ways we can add data into our tables. And so basically we need to learn an insert statement. So an insert statement works as follows. You say insert into, and now you give a table name. And then, however, this is somewhat optional. You want to open the parentheses here, and inside these parentheses, you want to put a column list. So basically ID, job title, salary. And it does not have to be the same order that it is up here. Let's actually change it so that you see it better, right? I can have a different order here, but this is very important to have it here. And then one of the things you can do, you can just say values. And once again, you open and close parentheses, and inside the parentheses, we will now create a list of values that will correspond to these column names here, right? So the first value will be an ID, the second will be a salary, and the third will be a job title. And this is very important because if you write your insert statements with these parentheses here, then the order of the values here is defined by the order of columns here. So always the first value will be an ID, the second will be a salary, and the third will be a job title, no matter the order of columns in the table. And if you skipped this, then you would be dependent on the order of columns in the table, which means that if somebody, for example, recreated the table with a different order of columns, your insert all of a sudden might not work. So best case scenario, it will crash. In worst case, you will insert something and not even know that you have inserted something incorrect. This is why it's very good that you actually go ahead here and write always the list of columns that you have here. I mean, you don't even, to be honest, you don't even need to do it by yourself. If you just grab a table here, pull it here in SQL Developer, you can just say that you want an insert and you can click apply and it will generate something like this for you, right? So here you have the list of columns generated. You don't even have to write it. And most programs, like most SQL editors, allow or do something like this for you. But going back to our small little example, let's say that we want the ID to be 1, we want the salary to be, I don't know, 10,000, and we want the job title to be a developer, right? And let's say, let's Control plus Enter, and we have that information that one row was inserted. Let's check that out. Let's select start from jobs and we can see this one row. Okay, but we wanted to say to see the not null in place. So let's copy this below. Let's skip the ID here. And this is very important, right? You do not have to have all the columns here. You can skip columns here, no problem. So then we want to add, let's say 20,000 and let's say a DBA. So a database administrator, of course, earns more than a developer. Now let's execute this part. And now we get an error saying that we cannot insert null into the name of my user. So basically your default schema, then .name of the table and the name of the column. A pretty nice error message. So we already know that we are violating this not null constraint. Let's remove it and let's recreate the table. So now once again, we'll insert the developer, no problem. And we try to insert the DBA. And this time it works. We have the DBA and it has a big null value in the ID. This is usually not something that you want to have. Therefore, I'll add back the not nulls here, not null, and not null, because every job needs to have a job title and every job needs to have a salary. I will take all of this, execute it once again, and once again, we have violated the not null constraint because now I need to add the ID right here. I recreate it and we have two rows now in the jobs table. So what you might also want is that the values in a column are unique. So what you need to do now, for example, the ID. So usually the convention is that something called an ID usually should be unique in a table. So basically one value should be in one row and one row only. You can do that very easily just by going into here and just saying primary key. So here, if you create a table like this and then go refresh it here and then go into the jobs table and then go into the constraints, you should basically see that there is a primary key created. So here you can see your primary key. On top of that, you can see the three constraints here, basically the three columns which are not null. So these are all your constraints that we have here. So now we have a primary key. And for now, it's sufficient that you understand that a primary key ensures a uniqueness of a row, so ensures a uniqueness of values in a column. So in other words, one value will be in one row and one row only. And it also ensures that the values there are not null. So this is actually redundant here. You could remove it. And now let's test it. Let's try to insert something that does not have a value here. And we get a notification, basically very similar to the one we have already gotten, that we cannot insert null into our column right here. So basically primary key makes a column unique and it makes the column not null. It also, and this is something that we will take a look at afterwards when we'll be talking about general performance, it's very good to query by this column. So if you now wanted to retrieve some rows from this table, the fastest way to do it would be to use a where clause on the ID column. So this is the primary key, and we'll go back to the primary key when we'll be talking about indexes. So here you can see the indexes folder. We can already see that we have an entry here. So this is, spoiler alert, our primary key, but we'll go back to this when we'll be talking about slightly more advanced features of our database. For now, I will leave it as a primary key. What else can we do? So we did not yet create a column with a date or with a timestamp. Therefore, I would add both currently. So I will add a column which will be called added DTTM, so added date time, and it will be a timestamp data type. So I'll just say timestamp, it will be a not null also. Underneath, we'll have the added DT, so an added date, that will be a date. And here I need a comma. Okay, so I now create it. And for now, I will maybe remove the not null because otherwise adding the rows will be pretty hard. Adding our rows still work. We need to add the ID back here. Now it should work. And we should have 2 rows here. We have the 2 rows, and here we have nulls. We will address that in a second. So what I want to do with this is I want this column to be an added, the timestamp of when a row has been added, and I want the date to be a date of when a row has been added. So essentially this will give us the same but slightly different information. So here we have the time also included. And how you actually do it is you say added datetime timestamp, and here you say default current, so here default current timestamp, and underneath we do the same thing. We do a default current date and we run it. Okay, name is still used because we need to drop it first. Table jobs was created. Let's try to add these rows now. And now that's very important, because what we've just done is we have added columns using the default statement, which make them, if we do not add any value right here in our insert statements, basically they are now filled by default, right? So here we can select it, and here you can see the 3rd of June. You have to trust me that where I am currently, it's 6:47 p.m. or 18:47 if you are using the 24-hour clock. And then the added date time is the 3rd of June, 2022. And this is how you can generate values in the columns using the default statement. Now, what else you might want to do is you might want to add or remove a column from a table. You can do that, no problem. You just go in here and say alter, and maybe let's go up here. You just say alter table jobs and say add. And now let's say test integer. This statement will add to our jobs table a test column, which will be an integer. Let's currently check if that was the case. And we can see at the end our test column with null values, because here we did not insert anything into this column. So now the columns are always added at the end, so to the right. And this syntax is slightly different on different database management systems. So if you are using something like Postgres, something like DB2, MySQL, it may be slightly different. So some do say add column here, and then the test, and then the constraint. So here you can see that Oracle already shows a syntax error. So in Oracle it's just add and then column name and the data type. Here we could also add a constraint. But if I run this now, this will not work because column is already existing. So what you should or can do is you can say alter table jobs, and now we can say drop test. Or here we have to say column, right? Oracle already shows us an error. So here there is no column and here there is column. So we just execute this, and our column on the jobs table is no more. We can add it once again as a not null. And what you can see here currently is that we are trying to add a not null constraint to a table that is not empty. What does this mean is it would add a column here and would insert null values, but it cannot do that because we have not null here. So we would need to specify a default value, right? So for example, a default 1. And then we do an alter. And here we get an error because this is here slightly wrong. This needs to be in this order. Now if I execute it, the table jobs was correctly altered. Okay, so we now have our test column. Let's check if we still have this. Okay, now what we can do is we can add these 2 rows back in. So now we can see that it's default 1. We have our dates, our timestamps, our dates here. So what we can do now is we can try to, for example, modify this column. So we can actually do an alter table jobs and then modify test. And now you say a new data type, say varchar 255. Basically, you execute it. And now you get an error that a column to be modified needs to be empty, because otherwise the database would need to cast the values that are inside there. Because if you remember, we have the default values here. Therefore, we need to drop the table, create the table once again. Now we can alter the table, we can add the column, and we can modify the table. And now the table is a character or a varchar table, which we can confirm by going here, left-hand side. We can select the test. Here we can see the 255 bytes. And then if you want to drop the table, we say, or the column, we say alter table jobs, drop test. I think here, once again, needs to repeat column. Okay. And now we can see that the table has been dropped. Currently we have no rows, let's add some. And we see that we have no column, or sorry, a column has been dropped. Now we can see that we have not, this column does not exist anymore. So here we have our jobs table, and we already have a primary key. We know what it is, so we know that it uniquely identifies a row in the jobs table or in any other table. So let's now make use of it, and let's create a relation. So let's create something called a foreign key. And the foreign key will reference the primary key such that we will not be able to insert a row into a table that we'll just create in a second, where the value of the foreign key column will not be existing in the jobs table. Right, so enough talking, let's create a table. So let's create a table. So here this table like describes a job, so like a position. And now let's create an employees table, right? So that it will basically store information about our employees. Okay, so here let's create tables employees. And this table employees will have the following columns. So first off, it will have an ID, right? That as always will make it an integer, and we'll make it a primary key. So this table can also have a primary key that this is not, and this primary key does not have to reference the jobs table in any way. But then let's make a job underscore ID. And I think it's a good practice to, in the column name, somehow reference the table where the primary key is coming from. But so far, we just make it integer. We make it not null. So it doesn't have to be not null, because null is also not possible to insert here. So it's not null by the fact that it will be a primary key or a foreign key, sorry. But we'll make it a foreign key in a sec, because this you make a little bit different. So here use, and then let's also make here perhaps the job title. Oh, here we have the job title. So maybe let's not make the job title, but let's here, I don't know, let's say manager ID. Let's make it also an integer, and every employee has to have a manager and something like this. Okay, it's entirely made up. We'll not use it anymore, so we can finish this at this point. Or we can, for example, add these two columns right here. Okay, let's currently try to create this table. And so far, we have not created a foreign key, right? Therefore, I will just add here a short drop statement. So now, employee, I think I made a typo. Copying is a useful thing. Okay, so here we have our employees table, but so far we have not made it a foreign key. So we have not created the job ID column as a foreign key. It's a normal column. To create it as a foreign key, you must say constraint, and then a constraint name. Let's say a foreign key to jobs, right? So yeah, once again, it's always nice to have somehow here reference the table. So the parent table. So the so-called parent table. So we would call the table that has the primary key the parent, and here the foreign key table a child. And now we must specify what type of constraint this is. So this is a foreign key on, and now we here specify a column name. So here it will be job ID. So this is the column name from this table. And then we say references, and now the name of the table that it references and the name of the column that it references. So it references a job ID. So this job ID column references an ID column that is from the jobs table. Okay, let's create this. And let's currently check what do we have in the employee table, in the jobs table. Jobs. Let's currently run it. So we have the two rows. So let's try to do an insert into employees, values. And here once again, you should always say ID, job ID, and then manager ID, right? The added DTM and other DT columns are generated by default. Okay, and here we'll insert values. So here we must remember that job ID can currently be either 1 or 2. So let's first create, so ID will be 1, job ID will be 1, and manager ID will be 1 also. Let's insert this, and this should be inserted no problem. Let's write a select statement so that we can check this. Move this, oops, I moved this to a new line, and we execute this part. Employees, once again, I made a typo in employees. Okay, we have one row added, so this works. Let's currently try to make an ID 2, and let's, okay, manager can keep at 1. Let's try to execute it. One row was inserted, everything works fine. And here, let's now try to add a job ID 3. And now we'll get an error, and currently the error that we got is that we have violated a unique constraint, and this is because we are trying to add an ID that already exists. But if I fix this, we will get an error that an integrity constraint, the FK jobs, was violated and the parent key was not found. And the parent key is on the jobs table. So if we wanted to fix this, what we would need to do, we would need to first, into the jobs table, we would need to insert basically an additional row that will say an ID, job title, salary, job title, salary. We would need to insert an additional row that has an ID 3, job title, manager, and then a salary of whatever. We would need to insert this, and we get an invalid identifier because I made a typo in the column name. Okay, so one row was inserted here. So if we now select from the jobs table, we can see now 3. And what's more important, or what's most important, we have an ID 3. So currently we can insert this row into the employees table, no problem. Okay, so these are the primary keys and foreign key relations. And this is important if you decide to define this sort of relation, because it's important that if you want to add data now, you need to do it in a specific order. So you need to load the parent table first and the child table second. Otherwise, you'll get these constraints violation errors. And don't be surprised if you're in your work, you don't technically find it defined in the database, but only as a logical relation. So very often you would put just in some kind of design or a mapping sheet this relation, and you would not actually create it in the database because of the reason that I just mentioned. So there it will make it a little bit more difficult to insert data, but on the other hand side, you get the data quality check that is also very important. Okay, this would be it for this episode. I think we have covered quite a lot of information. We have learned how to create tables, how to add columns, remove columns, how to modify the columns. We have learned also how to insert rows into the tables. So I think you now should have a good understanding of how all this works. We have also learned about the data types and relations between tables. I would highly encourage you, try to create just some tables, some random tables. There are amazing exercises you can find about this online. And I think that will be it for this episode. In the next episode, we will take a look at views. But this is still to come. I would like to thank you all for watching now, and I will see you in the next episode.